You existed through an entire life before you even reached 3 years old. You were brought into the world. You first opened your eyes. You heard your mother's voice for the very first time. You experienced food for the first time. You managed your very first steps. You spoke your very first word. And yet none of it remains in your memory. Not even one single moment. Most people think the explanation is straightforward, that your brain simply wasn't developed enough yet, that you were just too young. But that explanation isn't fully correct. And the real truth is much more unusual than most would expect, because your infant brain wasn't failing to store experiences. It was actually capturing everything. Your memories were being formed, but something later erased them. In 1905, Sigmund Freud was the first to define this phenomenon. He named it infantile amnesia. We know for a fact that babies are capable of memory. In the 1980s, psychologist Carolyn Rovi Collier at Rutgers University carried out a simple but powerful experiment. She attached a ribbon to a baby's ankle and connected it to a mobile above the crib. The infants quickly discovered that kicking made the mobile move, and they found it enjoyable. When she returned days later with the same infants, they still remembered. They immediately began kicking again. Even babies, as young as 2 months, could retain that memory for several days. 6-month-old infants could remember it for weeks. So infant brains are clearly capable of learning. They can store information. They can also retrieve it. But these memories do not persist over time. By adulthood, they are completely gone. And for many years, scientists could not fully understand why. The first part of the explanation lies in brain structure. The hippocampus, a small curved region deep inside the brain, is responsible for forming memories. It allows lived experiences, such as birthdays, conversations, or walking in the rain, to be transformed into episodes that can later be replayed mentally. In adults, the hippocampus works alongside the prefrontal cortex to label, store, and retrieve these experiences. But in infants, this entire system is still immature. The connections between the hippocampus and the cortex are not yet fully formed. Important regions like the dentate gyrus, which helps process new memories, only fully develop between ages 2 and 4. So an infant's brain can create short-term memories, but it cannot properly transfer them into long-term storage like an adult brain can. However, that is only part of the explanation, and what comes next is even more surprising. In 2014, 2 neuroscientists in Toronto introduced a theory that changed how infant memory is understood. Sheena Jocelyn and Paul Franklin at the Hospital for Sick Children proposed something that initially sounded almost unbelievable. What if the same process that builds the brain is also responsible for erasing its memories? Here's what they meant. During early childhood, the hippocampus produces neurons at an extremely high rate. This process is called neurogenesis. It is essential for development. These new neurons form the circuits that will support all future thinking and memory. But Jocelyn and Franklin believed there was a hidden cost. Every time a new neuron integrates into an existing network, it disrupts the connections already in place, including the ones storing memories. To test this idea, they experimented on mice. When neurogenesis was artificially increased in adult mice, those mice began forgetting previously learned tasks. When neurogenesis was reduced in infant mice, those mice retained memories for longer than usual. Their findings published in the journal Science led to a surprising conclusion. The infant brain is not weak at storing memories, it is simply too actively changing. The same rapid neuron growth that builds the brain also overwrites the information stored inside it. Early experiences are not lost because they were never saved. They are lost because the brain is constantly rebuilding itself, replacing old neural structures with new ones. But there is another layer to this explanation, and it may be the most unexpected one, to form what scientists call autobiographical memory, the ability to mentally relive personal experiences. You first need something fundamental, a sense of self. You must understand that you exist as a separate individual, experiencing the world from your own perspective. Developmental psychologists Mark Howe and Mary Courage argued in the late 1990s that this is a crucial missing element. Before roughly 18 to 24 months of age, infants do not recognize themselves as independent beings. A classic experiment demonstrates this clearly. A small mark is placed on a baby's nose, and the baby is shown a mirror. Before 18 months, they respond as if they are looking at another child. They do not attempt to touch the mark on their own face. After 18 months, their behavior changes. They realize the reflection is themselves. This moment of self-recognition closely matches the age when autobiographical memory begins to form. In other words, you cannot remember being a baby partly because there was no stable you to attach those experiences to. There was no internal narrator organizing events into a personal story. This raises a difficult question. If there was no continuous sense of self, and the brain that held those early experiences was later completely rewired, is the baby in your old photos truly you? Or is it something else entirely? A being that once lived in your body, but whose mind was gradually dismantled and rebuilt, neuron by neuron, into the person you are now? There is still one final piece: language. Developmental psychologist Catherine Nelson spent years studying how long-term memories are formed in children. She concluded that language does not simply describe memory, it organizes it. Before language develops, experiences exist as raw sensory fragments: sounds, textures, emotions, and light. But without words to structure them, these experiences lack a stable framework. Once children begin speaking, and especially once they begin discussing past events with adults, their ability to form lasting memories increases significantly. Language gives memory structure. Without it, experiences are like water without a container. They exist briefly, then disappear, and this is not just theoretical. Psychologist Chi Wang at Cornell University discovered that the age of earliest memories varies across cultures. In Western cultures, where parents often talk to children about past experiences, first memories tend to form around 3.5 years of age. Among the Maori of New Zealand, where storytelling and personal history are deeply emphasized, earliest memories can go back to around 2.5 years. In some East Asian cultures, where early narratives focus less on individual experience, first memories often begin closer to age 4 or later. This means culture actively shapes how far back your memory can reach. So what actually happened to your earliest years? Your hippocampus was not yet ready to store long-term memories. Even as it developed, rapid neuron growth kept rewriting its own circuits. You had no stable sense of self to anchor experiences to, and you had no language to organize those experiences into lasting structure. It was not one single cause. It was everything happening at once. Like every human being goes through this process. Every person you know has a blank space where their earliest years should be. And the reason is not that the brain is too simple. It is because the brain was doing something far more important than remembering. It was becoming you, and in the process, it had to erase what existed before.